Good day everyone. Today we will be presenting key data on the world tourism economy. My team, No Izzati, Siti Shafika, me and No Aziz Fazila, together we will explore global tourism trends, economic impacts and insights that shape the travel industry. Let's begin our journey into the numbers behind world tourism.
The dataset that we get from Kaggle website contains economic and tourism-related data across multiple countries and regions. So the dataset spans several years and provides valuable insight into the economic impact of tourism on different countries. The inclusion of both tourism metrics and broader economic data allows for an in-depth analysis of the relationship between tourism activities and overall economic performance. So how our data relevant to the economy is because it allows for an analysis of how tourism affects economic indicators like GDP, inflation, and employment rates. It also can gauge the economic importance of tourism for different countries, region, and time periods. It can be used to examine the relationship between tourism and macroeconomic factors such as how fluctuations in tourism impact inflation, unemployment, or overall economic growth.
Our methodology, we first cleaned the data by removing missing value and outlier and selected the most important features. We used two main models, linear regression to see how different variables affect each other, like how tourism impacts GDP. Classification to predict categories, such as whether a country has high or low GDP. Finally, we check our result using a currency score for classification and error measurement like RMSE and R-square for regression.
So now we move on to results and discussion. So for the first step in data pre-processing, we identify any missing values and duplicate values. So as we can see that in the red circle here, there are a lot of missing and duplicate value detected. So we clean the data using the command given, and we can see that there are only 1,608 entries after cleaning rather than 6,650 entries. So the second step in data pre-processing is to clean the outliers. So first we check the outliers by using box plot for outlier detection by the command given. So we can see that there is a clear presence of outliers for GDP and some outliers for other variables. So to clean the outliers, we use log transformation, and from here most of the outliers were clean, but there are still some outliers. Thus we need to do interquartile range to clean the rest of the outliers. From here, we can see that there are lesser outlier than log transformation after we did the interquartile range. Therefore, we can conclude that this is the better version of the data. Next, we move on to exploratory data analysis. So, tourism arrival have the highest standard deviation, which is 2.15, indicating the largest fluctuation in the number of tourist arrivals. And tourism expenditure has the lowest standard deviation, which is 0.35, suggesting that the expenditures by tourists were more consistent compared to other variables. So tourism-related variables such as receipt, arrivals, export, departures, and expenditures exhibit moderate variability that can be indicated by standard deviation. Economic variables like GDP have a wider range and higher variability, indicating fluctuations in the economy over the period analyzed. So inflation and unemployment rates show lower variability, which may indicate relative stability over the analyzed period. For our correlation heat map between other variables and GDP, both tourism receipt and tourism departure have strong positive correlation, which is 0.9, with GDP suggests that these factors tend to increase when GDP increases. Tourism export has the lowest correlation with GDP, which is moderate negative correlation, negative 0.41, meaning as tourism export increase, GDP may slightly decrease. Tourism expenditures, inflation and unemployment have weak or very weak correlation with GDP, implying the relationship with GDP is minimal in this dataset. So we move on to our box plot. So here the box plot shows a central tendency of the tourism receipt with a spread from approximately 20 to 25. It indicates that the data is fairly consistent with few outliers. So departures are mostly centered around 15 to 17, with the plot showing no significant spread or outliers. So for tourism export, it mainly ranging from 1.5 to 2.5. So there are a couple of potential outliers on the higher side of the data. So the central data for tourism arrival, that's between 15 and 17, showing relatively tight distribution with an outlier on the higher side. Next, the data for expenditure ranges from 1 to 2.5 with a tight spread, suggesting low variability in tourism expenditure. So the inflations are between 0.5 and 1.5 with a consistent middle value and no significant outliers. GDP values appear to concentrate around 36 with a spread from 20 to 30, showing moderate variability. Unemployment data is concentrated around the 2 mark, indicating low fluctuation with a few outliers.
For data modeling, we are using linear regression. First, let's talk about our data. We have several variables, including tourism receipt, tourism arrivals, tourism export, tourism departures, tourism expenditure, inflation, and unemployment. Our goal is to model and predict GP using these variables. We'll be using Python, so make sure you import NumPy and Pandas. For modeling, we import linear regression for sklearn linear model and train test split from sklearn model selection. Before training, it's crucial to clean our data. We remove any row with missing value from both the training and test set, ensuring our data is properly aligned. Once our data is ready, we split into training and test set. We then create a linear regression model, fit it to our training data, and use it to predict GDP values based on the feature in our test set. This process allows us to see how well our model can predict actual GDP values using each individual variables. Continue from the step in slide 1 and generate data plots for all variables. We first analyze each independent variable's relationship with GDP by looping through each predictor, such as tourism receipt, arrival, export, and so on, one at a time. For each variable, we extract the relevant data, remove any row with missing value, and fit a simple linear regression model to predict GDP. To visualize the trend, we generate 100 evenly spaced value across the predictor range. Use the model to predict GDP for each and plot a smooth regression line. We use the command as shown in the slide to perform this step and plot both the actual data points and the regression line for each variable. This process allows us to clearly see how each variable relates to GDP as demonstrated in the slide. As you can see in the slide, tourism receipt, tourism arrival, and tourism departure all show a strong positive correlation with GDP. This means that as this variable increase, GDP also tends to increase, which is clearly shown by the upward sloping regression line and the tight clustering of data point around those lines. On the other hand, tourism export display a negative correlation with GDP. Though the relation is not very strong, the regression line for tourism export sloped downward, indicating that as tourism export risks, GDP tend to decrease slightly, but the data points are more spread out and the trend is weaker. Now let's continue with other variables. As you can see in the slide, tourism expenditure show little impact on GDP. The data points are scattered and the regression line is almost flat. Inflation also doesn't show a strong correlation. The regression line is also slightly downward and the points are widely spread out. For unemployment, there are almost no effect on GDP. The regression line is nearly horizontal and the points are random. So among these variables, expenditure, inflation, and unemployment have little to no impact on GDP in our dataset. First, we use all the commands shown on this slide to get the function formula for our linear regression model. In the next slide, I will continue with the interpretation of this result. Here are simple explanation of the interpretation section from the slide. Tourism receipt and tourism expenditure have the strongest positive effect on GDP. When this increase, GDP goes up. Tourism departure also show a positive impact, but it's smaller. Tourism arrivals have a slight negative effect, meaning more tourist arrival alone doesn't necessarily increase GDP. Tourism export have a negative effect on GDP, possibly due to how the data is measured. Inflation show a mild positive effect on GDP in this dataset. Unemployment has a slightly positive effect, which is unusual and may reflect special circumstances in the data. Overall, the interpretation tells us which tourism and economic variable most strongly help and hinder GDP growth in this analysis.
Next is linear regression model evaluation. So here are the steps that we use to evaluate the model. Let's look at the model results for tourism and economic indicators. As shown in the slide, we can see that tourism receipts have the strongest link to GDP with an R-squared of 0.84, meaning they explain 84% of GDP variation and have low prediction errors. Tourist arrivals and departures also show good relationships with an R-squared values of 0.72 and 0.79, but slightly higher errors. In contrast, tourism exports have a weak relationship, explaining only 16% of GDP variation and showing higher prediction errors. Looking at other economic indicators, tourism expenditures, inflation, and unemployment all have very low or even negative R-squared values. This means these models perform worse than simply predicting the mean, and their predictions have the highest errors, nearly 2 units off on average. In summary, only tourism receipts, arrivals, and departures are reliable predictors of GDP, while the other variables show weak or no predictive power. Next is the limitations of the linear regression model. I will highlight three main limitations of our linear regression model. First, we only included a limited set of economic variables and missed key factors like exchange rates or government policies. The model also assumes a straight line relationship, which may not reflect reality and doesn't consider how variables interact with each other. Second, our dataset uses just a single time point, so we miss seasonal patterns, and it treats all countries equally, even though they differ in size and development. Finally, the model uses only one predictor at a time, doesn't handle outliers, and may be affected by skewed economic data or error patterns that differ across GDP levels. For improvement suggestions for linear regression model, the first one is we should use longer time frames, which means we can gather data across multiple years to better spot patterns and changes. The second one is test with more than one model. We should try different modeling techniques to see which gives the best results. The third one is group countries by region so that we can analyze countries by region or income level for more accurate comparisons. The fourth one is we should expand variable choices. We should add factors like infrastructure, currency rates, or government actions for richer analysis.
In this session, we use a classification method to analyze the relationship between variables, tourism, and economic variables and GDP. Since our dataset doesn't have a predefined high or low GDP category, we create a binary GDP variable by splitting the data at the median. This allows us to classify each country or entity as either high GDP or low GDP. We use matplotlib to visualize the data. For each variable, such as tourism expenditures, receipt, and so on, we create scatter plots. The x-axis show the selected predicted variables, and the y-axis show GDP. Each point is color red with high GDP and blue for low GDP. This helps us see how each variable relates to high and low GDP levels and identify potential thresholds that separate the two groups. Here, you can see a series of scatter plots for each variable. The red points represent entities with high GDP and the blue points represent those with low GDP. This plot makes it easy to distinguish between high and low GDP groups based on each predictor variables. By visually separating the data, we can quickly spot patterns, such as whether high GDP countries tend to have higher value for certain tourism or economic indicator, or if there's a clear divide between the two groups for specific variables. As you can see in this slide, all the graphs represent the distinction between high and low GDP groups. Overall, wealthier countries, high GDP usually have higher levels of tourism spending, receipt, arrival, and departures, as well as lower inflation and employment rates. In contrast, countries with low GDP often face economic challenges, such as higher inflation and unemployment and lower tourism activity.
The next one is classification model evaluation. So here are the steps that we use to evaluate the classification model. Now let's discuss about the result and interpretation. So the accuracy of 94.98%, which means that the model correctly classifies GDP levels 95% of the time. F1 score of 95.14% indicates an excellent balance between precision and recall. So the economic significance is that the model shows strong ability to distinguish between high and low GDP economies using tourism indicators alone. For class-specific performance analysis, the low GDP countries, class 0, the precision is 96%, which means that when the model predicts low GDP, it's correct 96% of the time. For recall of 93%, this means that the model identifies 93% of actual low GDP countries correctly. So the economic implication to that is that the model is excellent at identifying developing economies with limited tourism infrastructure. For high GDP countries, class 1, the precision is 94%. This means that when the model predicts high GDP, it's correct 94% of the time. For recall of 96%, this means that the model identifies 96% of actual high GDP countries correctly. For economic implication, the model is strong at recognizing developed economies with robust tourism sectors. Next one is limitations of the classification model. I will highlight the main limitations of our model. First one, it assumes everything is linear and mixes important factors like government policies or events, and it doesn't account for tourism seasonality. Second, the dataset is too simple, only splitting countries into high and low GDP, and it doesn't show how things changes over time or during different tourism seasons. Finally, the model itself is basic and may miss complex patterns, and if the data is uneven, like having many more high GDP countries, it might not predict the smaller group accurately. Improvement suggestions for the classification model. The first one is we should include more data. We should use data from several years, not just one, to see trends and cycles. The second one is we should balance the data. Make sure that there are enough examples in each group so the model can learn from all types. The third one is add other factors. We should bring in information about policies, major events, or even weather patterns. The fourth one is try smarter models. We should use more advanced models to capture more complex relationships. The last one is we should add more categories. So instead of just high and low, try low, medium, and high GDP for more detail. To conclude, briefly, tourism receipts are the strongest predictor of GDP, while arrivals and departures also show good predictive power. Other factors like exports and inflation have weak links. For policy, attracting higher spending tourists is important, but remember, our results are limited 1 year and don't capture complex economic relationships. That's all from our group. Thank you.